NumPy is fast, but how can we make it even faster? Stay tuned to find out. Welcome to AI Adventures, where we explore the art, science, and tools of machine learning. My name is Yufeng Guo, and on this episode, we're going to look at a new library from Google Research called JAX and see how it can speed up machine learning. JAX can automatically differentiate native Python and NumPy functions. It can differentiate through loops, branches, recursion, and closures. And it can take derivatives of derivatives of derivatives. It supports reverse mode differentiation, also known as backpropagation, using the grad function, as well as forward mode differentiation. And the two can be composed arbitrarily in any order you want. It can seem kind of like every other library these days supports auto differentiation, so what else can JAX do? Well, it's also able to speed up your code, sometimes really significantly, by using a special compiler under the hood. Accelerated Linear Algebra, or XLA, is a domain-specific compiler for linear algebra. It can perform optimizations like fusing operations together, so intermediate results don't need to be written out to memory. Instead of this time-consuming process, this data gets streamed right into the next operation, and this enables faster and more efficient processing. JAX uses XLA to compile and run your NumPy programs on GPUs and TPUs. Compilation happens transparently, with NumPy library calls getting sped up. But JAX takes it a step further than XLA alone, as it lets you just-in-time compile your very own Python functions into XLA-optimized kernels using a single function API called JIT. Compilation and automatic differentiation can be composed arbitrarily, so you can express sophisticated algorithms and get maximal performance, all without leaving Python. What else is there other than JIT? There's also Pmap. Applying Pmap means that the function you write gets compiled by XLA, just like JIT, and replicated and then executed in parallel across devices. That's what the P in Pmap stands for. This means you can do compilations on multiple GPUs or TPU cores all at once using Pmap, and then differentiate through them all. JAX boils down to an extensible system for composable function transformations. The main ones today are grad, JIT, Pmap, and also Vmap. Vmap is used for automatic vectorization, allowing you to turn a function that can handle only one data point into a function that can handle a batch of these data points of any size with just a single wrapper function. Let's take a look at how this all comes together using a familiar example, training a deep neural network on the MNIST dataset. This notebook starts out by creating two utility functions to make a neural network with just randomly initialized parameters. I've printed out the dimensions of each layer for convenience. We can see here that it takes a 784 unit wide input and passes through two hidden layers whose size is 512 each. And the outputs are the usual 10 classes, since we're predicting what digit is supposed to be in that image. Next, we have a function that takes care of running an image through our predict function. Our predict function only handles one image at a time, and we can confirm this by passing in a single random image of the correct dimensions, which gives us a vector of size 10, representing the 10 logit values coming out of the final layer of the network. But when we try a whole batch of images, say of length 10, also it fails, since the array dimensions no longer line up. But we're in luck, because wrapping our predict function in a Vmap will allow us to take advantage of matrix multiplication and run all 10 images through the model in a single pass, rather than doing them one by one. The resultant function can handle a batch of arbitrary size, and we don't have to modify our function one bit. Notice that the output is now 10 by 10, representing the 10 logit values coming out of the final layer for each of the 10 examples in that batch. Now let's see how we can use the grad and JIT functions to build out the remainder of our model as well as our training code. We'll add in a function to one-hot encode our data and a couple more functions to calculate accuracy and loss. Finally, we'll put together our update function, which will take the result of the loss function and run grad on it, which will take care of the backpropagation for us and return the updated parameters of the model. Now we're almost ready to run our model. We just need to add in some code using TensorFlow datasets to bring in our MNIST dataset. JAX purposely does not include dataset loading functionality, as it's focused on program transformations and accelerator-backed NumPy. So now we're ready to train our model. Our training loop is set for 10 epochs, and we have a timer added in as well, because we want to see how it performs. So let's run this, and we can see that across 10 epochs, we end up spending about 22 seconds per epoch. Now, you might be thinking, wait, didn't Yufeng mention something about using the JIT function? Did we ever add that? Good catch. Let's add in the @JIT decorator at the top of our update function, and we'll rename it JIT update. Now we'll have a before and after comparison. Let's reinitialize our parameters using the same init network params function we used earlier, and then run our new training loop, and we'll see how the timing works out. Okay, so this is looking like it's taking way less time, only 8 seconds per epoch, and all we had to do was add 4 characters to the top of the update loop. Now that's legit. Before I close this out, I want to remind viewers that as of this recording, JAX is still just a research project and not an official Google product. So it's likely you may encounter bugs and sharp edges. The team has even made a list of gotchas and a gotchas notebook to help you out. Since this list will be constantly evolving, be sure to see what the state of things are if you plan on using JIT for your project. Thanks for watching this episode of Cloud AI Adventures, and if you enjoyed it, click that like button and be sure to subscribe to get all the latest updates right when they come out. For now, head on over to GitHub and try out JAX. Send over some bug reports and let the team know what you think.